Yeah, I know the problem now. Cool. I hope you guys can. Let me share my screen as the next step. Let me just share the entire thing because a lot of stuff is going to go on. So here's where we start. So I'll be taking you through modules 7 to 10 for this program, and it's gonna be a packed session, but I'll try to compress all the information as much as I can and focus on the most important parts. Otherwise, the information that's also provided in the documentation in the notebooks or elsewhere I'm confident enough it will be able to help you with your journey. So first things first, when we're talking about machine learning, if you've never heard of it before, machine learning is a different paradigm. And the first example I can give you is when you're trying to predict, or when you're like today when you came, how did you know that, for instance, like not to carry an umbrella today? Though the weather is looking weird in Nairobi, but you first observe like Monday, Tuesday, Wednesday. Oh, we are on Tuesday or Wednesday. So you looked at Sunday, Monday, and then it didn't rain on Sunday and Monday. So when you came here, it said that, hey, I don't need to carry an umbrella, right? So you used the information that you experienced in the past to say, hey, I shouldn't carry an umbrella today. But now for the paradigm for machine learning, it's like your computer learns that whole pattern, right? You teach it how to learn that pattern. So you give it a bunch of data in an organized way. So you can think of your arrays, your matrices, you've heard of that. So arrays, like just a bunch of numbers, or a matrix, which is just rows and columns of numbers. Think of your Excel sheet. So you need to feed your computer that kind of information with those particular answers. So the answer is it going to rain tomorrow? And the data is, you can think of all these things that the meteorological department has collected about weather. You put that comes in as your data. Whether it's going to rain tomorrow is now your answer, right? So if you put that together, this machine learning model that you're going to make after giving it all that information is going to figure out what are the rules to predict, hey, it's going to rain like today, right? So that's the paradigm. So it's kind of something like familiar, right? So that's what goes on with machine learning. So here, just to summarize, a human being makes predictions based on past experience, and the predictions made by the computer, it's done through data. So that's just it with machine learning. Hopefully that'll help you pass your CAT. That's what you asked. So another thing about these problems in machine learning is how you structure them, right? So if there's a way you can take your problem and convert it all into a bunch of numbers, that's when you can pretty much solve a lot of stuff. But here, when I say that, your input is like in form of data, and then within this thing called a neural network, you put it through, you put your data through there, and then it's transformed. You can think of it as when you multiply numbers together, right? Let's say 2 and 2, you get 4, right? But this time it's not that like black and white. There are more transformations that occur. So there's depending on what you're using, if you've heard of linear regression, y is equals to mx plus c, there's a number you add, like the one for predicting weather. Let's say, hey, I am going to a point where I'm going to make this presentation so long. So let me just give you the whole overview. So what you have here is how the neural network works. You give it the data, and then it's going to transform it into other forms. And then here, your prediction will be just thinking about the previous example we had for predicting weather. So the prediction is what's the weather today, right? And then Okay, sorry, the true label is what's the weather today, and then the predictions is what the model will figure out that if you give me this data in this certain way, these are the predictions I'll get, or what the model thinks that is the answer, right? And then if you put those two together, you need to find a way, or you need a metric to show you that how you're doing, right? So like if you take those two values that are generated, so the model will just give you like this array of numbers. This is the prediction, right? And then you already have an array. You know what's going to be the prediction if it's going to rain, right? And then when you put them together, when the model is trying to estimate, you need a way to figure out that this model is actually doing well. And it's very, it would be nice if I had a diagram, but that will come later. So you have a bunch of points, then your model is trying to estimate, right? So you can do a simple subtraction, the predictions for the model and your true labels. If the labels are very close, if the subtraction, if you subtract two numbers and they are very close, like 1 and 1, you get a 0, right? Now when you do this over and over again with this whole neural network, these numbers, when they are mostly small, when here right now our loss function is just subtracting the prediction and the predictions and the true targets. If those numbers are small, that means it's very close to the ideal value, right? But if it's far away, it's going to be something really bad. So let me just draw this, because I hate putting. So this is what's going on graphically. So you have a bunch of points, right? Okay. So essentially what you're doing is when you're here, when I'm talking about this loss function, your data looks like this if you plot it in a graph. That is if you're just comparing two things, right? The prediction is going to rain tomorrow and the factors influencing. Let's say it's one thing, right? So you have your y and your x. So what's going on in this loss function is we are trying to estimate what's the best line that's going to fit this data, right? That's what's going on. So when you're training your neural network, it's finding ways of fitting this data. And ideally, with the way this data looks like, I think the line that fits most points is something like this. It's not to scale, but it's okay? Okay. So there's a diagram I'm drawing here. I don't know how the guys online will get it, but if someone can take a photo and then send it to them, that I'd appreciate. So what's going on is, with our problem is, like, we are trying to estimate a line that's going to fit this data, so that if you get more data, we can just say, hey, the point is here, and we go to predict, right? So that's essentially what you're doing here. And what's happening is, as the model is trying to figure out what's this line of best fit given this data, what happens is, if your equation is super complicated, you start getting numbers, lines that look like something like this. But most of the time, this one is known as ideal, right? Because it's even harder to explain this than this, right? So that's what's going on with this loss function here. It can be something like mean squared error. It can be something like what's the other one? Yeah, that's the one that came to my mind. And then when you find the values, what happens is you have a certain number that you can compress all this information into a single number to know how you're doing, and that's now called the loss score, right? And then what's happening while you're training your model, these weights are updated. So what that means is, if you have a formula like for prediction of rain, so you say maybe y is equals to, maybe humidity is, you can call it x2, no, yeah, something like that, and then plus, I don't know, since this is a positive 9, maybe 6, right? So if you get a number here, add it, you get the prediction 7, right? So something like that. But now if you have a very complicated formula, you get something like x1, I don't know, x3, x4, yeah, something like that, and then 6. So which one is easier to explain, this one or this one? Yeah, the first one. So ideally, the first one is something like this straight line, and then the second one is this. So what you're trying now, when you're trying to find these numbers over here, the numbers that correspond to this, is you tweaking this what do you call it? This whole equation, and then like when you're tweaking the what do you call it? Sorry, when you're tweaking the calculations through something called gradient descent, this weight update happens, and then the numbers that are supposed to be here, here I'm being very complicated, but it's supposed to be a nearly a number like this, right? But now, when you tweak these numbers, now this is what corresponds to the weights, they are tweaked, and then you get a certain number. Yeah, that's the roundabout way of saying what's going on with machine learning. Does anyone have a question? Yes.
So all that guys are asking if they can see what they're doing.
Yeah, I don't know how I'm gonna do that, but okay. My camera is off. Yeah. This is so weird. Effects are. How do you put effects off? And then I do effects, and then I put off. This is terrible. Yeah, I've put no effect. That's all mine is. Is that better? So this is what I was explaining for the guys online. Ideally, when you're trying to predict the weather for today, this is like the most This is the most simplest way of putting this explanation. Let's say you just want to predict one thing. You have y and the y-axis and the x-axis, right? But then if you're just taking one thing, and let's say you have your data that looks like that, those x's you're saying there, like what happens is we're trying to find the best line that's going to fit this data, so that if you're given another random data point, we'd possibly do the prediction code, right? So that's essentially what you're doing in that whole diagram I showed you. And we want a formula that summarizes all this, and that's essentially the model. And right now I was explaining sort of linear regression and the least squares line, like theorem in a way. So that's what we have over here. And we are saying if you have like a complicated like equation over there, we get a bumpy polynomial line over there. But then if you have a simple formula, we get a straight line like that. And that's essentially what we are doing over and over again. So if you have those coefficients there, those x2, x3 things, and essentially they're supposed to be numbers so that it's easier to explain. But yeah, when you have the second equation over there, you have a very complicated polynomial thing. But then if you have the first one, it's a bit simpler. And essentially, that's what we are trying to create with that whole process I've been trying to narrate. And yeah, so if you get more data, your values are substituted there, and then you get the prediction. Is it going to rain today? It's either yes or no, if it's just a classification problem like that. So yeah, that's essentially that diagram. Yeah, this diagram. Let me see if I am screwing up again. Okay. Okay, someone's asked if they missed the last module. So we are doing it a bit differently this time. We are starting with the module 7 to 10 because last week we spent so much time in the other modules, and then we're just doing this, and then maybe we'll go back to the other ones. But don't worry, like you can just review the stuff that we've shared, and then you can follow it step by step. Yeah, so that's this diagram. So now let's just dive into the Google ML APIs and Gemini. And over here, we're going to look at various services that Google provides, like for doing vision AI, natural language processing, speech to text, text to speech, and video intelligence. And so we're gonna use their normal services that they provide, and then we are gonna use the ones that are concentrated on the Gemini's multimodal capabilities. So if you've gone through the blab that we had, that you're supposed to have set up your Google Cloud environment so that you're able to set up and have access to various services. So if you have set up, you'll have something like this, and then you will look at your services. So I've enabled a couple. So like if you follow step by step what I've put over here and the APIs you need to enable, you'll be good. So yeah, so these other related stuff I'm going to go through later, and again I'll be as short as I can. Yeah, because this stuff is a lot. So I'll assume you've already set up. So we'll just jump into the actual content. Let's start with this first code cell over here. So it's always good to know what sort of Linux distribution you're running in this Colab environment. And this is essentially the bash command that you run. And here you say you're using Ubuntu 22.04, LTS, and this. So this is usually essential because, like, when people are making these notebooks, you're going to be collaborating with a lot of people, and when you're making your your Docker images, as an example, it's always nice to have this. So whatever you have here will be the same as what you have in your Docker environment, right? So another thing good to know is whatever Python version is running here, and here using Python 3.12, and also finding out what sort of Google Cloud capabilities we have here. And here in the Colab, we have all this functionality, but we don't have Africa's Talking installed according to this list. So what do? Install it. So here I'm going to install Africa's Talking and some other utilities that I need to go through this notebook, and here they are. So that's completed. And then it's also nice to show like the actual packages and who are the authors and stuff, because people do weird things in these package repositories, especially if you're not careful. So sometimes it's also good to audit and see who exactly wrote this, what's their homepage, and yeah. So there's the example there. And then you import the packages that you need for this particular tutorial. I always like having them in one place just because of the transition between notebooks and Pi files. And when you have your imports all over the place, like it becomes a bit difficult to find specific things, or you might lose something. And then, yeah, so that you don't freak out, just have the imports in one place. So this information here is related to data preparation, and I will not go through it in this session, but please feel free to go through it. So the first thing is the Google Vision API. So this one allows you to get insights from images, and what we'll do here is we are just going to load our credentials, and then we are going to give it we're just going to load up the utilities that you need to do the inference. So that means you're doing prediction. You're asking this model, like, what is in this image, right? So that's what's going on with this function you have here. And the image you are going to query with is this one over here, which I have opened. So this is a cat saying, wake up, human. So let's see if the computer is able to figure out it's a cat. So here it says it's a cat with a 0.99 accuracy score. And these are other things to do with the scientific name, which is, at least from what I remember about scientific names, it's all right. And it's a carnivore. Yeah, so all this, though this is now, if you remember the diagram for prediction, this is what the model has predicted what this is. And here we have just utilized like Google's uh, Vision API to do that, which if you have, if you've signed up and you have the credentials, you can easily just use my code to actually run it and get it. So you also need these GCP credentials over here, which are also loaded in my environment somewhere here. So if you don't have those, you'll not be able to do this. And I've also noticed, like if you're using VPN, this won't even work as well. So you're gonna have to turn off your VPN, at least for this actual presentation. So this can be something else. I'm assuming they're using something called ImageNet to train this model. So ImageNet is just a collection of images that were like curated for a lot of things in the internet. And then they train this model, and then it gives you like a ton of predictions of what this is. And so if you go online and look for ImageNet, and then you maybe grab random images and then give it and put it here, it's most likely to give you a prediction that is at least in line with your image. If you want something else, you'll need to do something called fine tuning. What that means is, if you remember the diagram, just come to the diagram here. Yeah, if you remember this diagram, so there's these weights that you're supposed to tweak. So weights are those coefficients you have there in your equation, and then once those are tweaked, you can change from like, hey, this is not you're not trying to predict all these random things. You're maybe trying to predict these types of trees or these types of cats or dogs, as an example, and then you'll be able to have now a system that's able to detect cats, dogs, or maybe trees. So that's awesome. The next thing you can do is you can annotate an image. So what that means is you can add things to do with bounding boxes, like, hey, as much as you're predicting this is a cat, can you like actually identify where the cat is? So you can draw a like box around where the cat is. But here what I put was, this looks like an image of somewhere in Nairobi. Just I wanted to see whether it's able to, or the model is able to detect buildings. So let me see. It's taking some time. Okay. So let me see if there are any questions. Hi, can someone share here a link to the notebooks? Okay. So I will share the link to the notebooks. Let me just stop sharing for a bit. Oh, I've lost my tab. I think I am here. So we are back to the model and annotating. So here we have identified a couple of buildings, like some of these may be familiar to you. Can anyone identify a building that they know over here? Okay, I'm hearing KICC, which is, I think this, another building, Times Tower. Okay, Times Tower. I think Times Tower is, I think here, right? The tallest. Dude, I don't know. Or this Scope House, I guess. Yeah? This one here, right? Or this one. Man, good on you. I'm bad with some buildings in Nairobi. I only know the KCC one, and this one is, I think, Cop House or something. Yeah. So as you can appreciate here, the model is able to identify buildings here. So there'll be a lot of use cases like this in this notebook. IoT related, like this could be a drone, like going through buildings and trying to like figure out how many buildings are in Nairobi as an example. I don't know if you're able to do that. So another one is, so we've covered the vision API. We've seen the model is capable of identifying what's in an image. Like you saw, it identified the cat, even the scientific name and the things around it. And then the second thing we have seen is annotation, where bounding boxes, this green box, rectangles and boxes here are able to be drawn on objects to show like, hey, this is a building. So you can use that for other things like identifying cells, minerals in the earth, if you have data like that. Yeah, but here it's up to your imagination. So the second thing is now for natural language processing. They have this cloud natural language API, which understands, which helps like annotate text. And a very common use case is called sentiment analysis. That's where you give like the computer a bunch of text, and it's able to identify, hey, the sentiment of this text, or the best word is, what is there's a word, I don't want to repeat sentiment. Yeah, okay, you can say tone. In a way, you can say the tone. What's the tone of this text? Is it positive? Is it negative? Is it neutral? And that's what we can do here with this handy dandy function here. And here I give it a bit like text here. I love using Google Cloud Natural Language API. It's powerful and easy to use. So that is more of a positive sentiment. So let's see what the model comes up with. So you get a score of 0.9. That is like, the way this thing is like or the way the scores are given for this metric is between 0 and 1, and values closer to 1, which is like this one, 0.9, means it's very positive. And there is the other text, which is the negative one. I am very disappointed with this service. It's slow and unhelpful. So here it gives you a negative value. So let's just say the skill is bigger. It can go also to negative. So 0 to 1, and then negative scores give you like, well, just say up to -1. Let's say -1 to 1. That is the range. And the stuff towards the positive end, the positive numbers, those are the positive sentiments. And then given how closer it is to 1, it tells you how positive it is. And then if it's away from 0, close to the negatives, it's very negative. Like here, this one is 0.8, so that means it's super negative. So there's that. And then there's the sentiment magnitude, which I feel this one is more of a score that I did not review, but you can go through it and find out. But here it's if I can give a rough guess, it just gives you like how the weight, like how much, how positive or how negative is this. But please just read the documentation to get a better explanation about that. So there's also this syntactic analysis. This is where now you're breaking up text and figuring out what it is, or in English, what is it? Like in English, like is it a noun? Is it a adjective? Is it a pronoun? So this comes in handy, especially when yeah, so I was saying this comes in handy, especially when you're going through text and you're trying to like extract some text from maybe insurance information, and then you're trying to maybe get like, maybe when did this person start using this insurance service and things like that. You want to do it in scale. You have a ton of documents, and then you have like this model that is now processing this for you. And yeah, this can come in handy in situations like those. So we run the handy dandy function there. So we have the text we are going to give the model is the quick brown fox jumps over the lazy dog. And then what you get is this, like this is a part of okay, there's the quick, which is an adjective, as you can see there. And fox is a noun. It also tells you where the location is. Then jumps is a verb, and things like those. Yeah, but I think the one that I was trying to tell you about is for there's a word. It's not coming to my mind, but I will remember. So these are the kinds of things you can do with the API, the natural language API. Another thing you can do, this looks like the same thing. Oh, this is now you can give it a sentence like this, and then, oops, what did I just do? Yeah, this is now identifying what's going, or specific things in the text, which we are calling entities. And here we are looking at, based on this text, it's telling you, hey, this is a work of art based on this. So it's grabbing this text, converting it into a numerical form, and then based on its training, for the task, it's able to figure out like, hey, if you give me this text, I'm going to extract specific entities that explain what's going on in this text. And this sounds like a story from the Norse mythology. And as you can see here, it says Old Norse. And the reason why I said Norse as well, just from my brain, is because I'm seeing Odin over there. And Odin is a famous character in the Norse mythology. So yeah, this is, I think, an example if you're going through the information from the cold labs. So yeah, just dig through and then put your own text here and then try and learn what the limits of this model are. So we are done with just looking at text. Now let's look at another version, which is now audio. And here we are going to utilize the Cloud Speech to Text API. I wrote a function for this as well, and I got a file from the object storage here. And if I run this, or you can also use your own audio file. So what happens is this model is able to convert your audio to text. So this can come in handy like in presentations like this, like where you need to get all the text that I'm saying, maybe to refer to this later. Or another challenge you could do is maybe wherever this is uploaded, you can grab the video and try and extract the transcript of everything I'm saying and identify speakers as well. That's a good challenge that you can try, especially be able to identify the specific speakers, because I've said my name, so at least that one you can identify. So that's speech to text. Now let's move to text to speech. So this is where now the model is able to generate like human-like audio based on some text you give it. So if I run this handy dandy function here, where I give it text, hello, this is a demonstration of the Google Cloud text-to-speech API. I made a widget over here to be able to play the audio.
Hello, this is a demonstration of the Google Cloud Text-to-Speech API.
Yeah, so those are the things you can do with the API as well. And also we have a text-to-speech system in Africa Stock, which you can try. And then here is another one for the Cloud Video Intelligence API. If you want to analyze video, like again, the video we have here. So here are two challenges for you. You can grab this video wherever it's uploaded. You can grab the video and you can grab the audio. There are ways of doing that. And then you can use these APIs that I'm introducing you to extract information about this video, like what am I wearing, or am I wearing glasses and stuff. Yeah, you can try use this as a challenge to do that, or any video that you have, to be honest. And let's run it. This is again something that is provided by Google in the object storage over here. And I made a widget to, I don't know if this works. Probably an error. But what was in the video is, it's just giving like, okay, what was going on? It's transport of a certain vehicle, as you can see over here. So where this can come in handy is in factories, like let's say a milk factory that puts like milk in these glass bottles, right? There's a part where, like in the conveyor belt, as the bottles are coming through and liquid is being put in, you can also put a sensor, like, hey, if you find a liquid that's broken, a bottle that's broken, or liquid is spilling somewhere, send a notification to the people who are in charge today to be able to deal with that before it continues through the conveyor belt to be packed somewhere or cause chaos along the factory. So we have just completed like a couple of APIs by Google that allow you to do natural language processing, that's just processing text and making sense of it, uh, image analysis and video analysis, audio analysis, and also generate text for you. Generate audio for you. So I think I can take a small break and see if I have any questions here. I don't think this is the link folder that has the current you're on. So what I'm running here is actually a notebook that I had written in the past, but I'm running it on my personal Colab here. But if you have access, to be honest, you'll be able to see the same thing. I think like anyone else, like if you can help Kimani with the link and to this particular presentation, that would be nice. Do you have the link? Yeah, there was that problem. I wanted to, like, if MK could address it, but man, we're halfway through. We just continue. I'll just share it once I'm done, I guess. But hopefully, if MK sees it, he'll be able to share, because I don't think I have like permission to do the next steps. Sorry about that, guys. Anyway. Okay, my audio is working, hopefully. So let's just move to now the multimodal kind of models. And when I say multimodal, I mean that it's able to take in different sorts of data. So it can be audio, it can be video, it can be image, it can be text, and it's able to just take in all. It's just basically whatever we've done before, it can process all those kinds of modalities, right? And the trick is, at least from the paper by the Alibaba team that I read, I didn't read the Gemini paper, but there's a way they put the information together in something called an embedding. So they like squeeze it in, and then they're able to process these different types of modalities. And then you're able to get the normal, hey, this text description or this image description. But if time allows, next time I can go through that like more in depth. But basically in this section, we are just going to do what we did before, but with a single model. Because before we are using different kinds of models that Google has curated and put together. But this time we are using one model, which is the large language model, Gemini. Actually, I don't know if I can share. Okay, let me just take a short break so that I can give you this information as people show up and update the link over there. Because I'm so sorry, it's so hard for you guys to follow along and you don't have the actual files you need. So let me just quickly make what do you call this? Module 7 and 10. Oh, it's small enough. So I have temporarily made a link there where you can just download the notebook that I'm currently running. And yeah, if you can just give me a thumbs up if you've gotten it and you're able to see the notebook. Just use your, okay, there's one. If I get at least, how many are you? You're 23. Maybe, oh man, I don't have a lot of time, but let's just say the link is there. Great. So you can upload that in your, what do you call it? Your drive, open it in Colab, tuendelee. We continue. So we have our handy dandy credentials that you need to put here. So if you went through the previous, yes? Oh, I share my screen. Okay, great. Thank you. Yeah, so for if you came for the previous sessions, this is not something that you've never seen before, but this is how you handle credentials in Colab. There's this key icon over here. You click it, and then you're able to access your credentials safely like this. And then you use these handy dandy utilities that the Google team has created to actually take this information, GCP, project ID, and the location. Okay, I usually put this as a secret as well, but ask different people, they'll say different things when it comes to this particular information as secrets. But if it's your API keys and stuff, just put them over here like I've done over here, and you're able to access them safely. Including the service account JSON, make sure you can also put the whole thing there, just copy paste it, name it something, and then put it in. Yes. So over here, after initializing where you're running your project ID and your location, there's this function I've created here where I'm using the utilities that Google provides. And here we're using the model Gemini 2.5 Flash. You're going to give it an image and you're going to give it a prompt. Please describe the image in detail and what's happening in the scene. Remember, it's that cat again. And then let's see if the model will be able to figure that out. So here's the description. This is an image. This is a humorous meme featuring an orange tabby cat with an overlaid text, "Wake up, human." That's correct, right? Right. So there's this other pros. You get what's going on in the image, the lighting, and the interpretation. I think you can go through that maybe at your own time. And now let's see whether the same Gemini is able to do the sentiment analysis we did before. And here, I want you to pay attention to the prompts. Be as descriptive as you can and very to the point. This is what I want. Like here, I'm saying perform sentiment analysis on the following text, classify the sentiment, positive, negative, neutral, and a brief explanation. So it's always nice to tweak this. And when you're tweaking the prompt, most of the time, I don't write this. A model writes this because there's a way the text it takes into consideration, like the way it puts text together, it's able to extract the most if you tell it, hey, like, please fix this prompt for me from whatever it is you wrote. And I found maybe almost 99% of my projects, I normally just write my first prompt, and then I tell the prompt, I give the prompt to the model I want to use it with. I hope I'm not confusing, but I take the text that I have, give it to the model, and it's usually the model I want to use for the project. Like if I'm using Gemini, I use Gemini to refine my prompt, and then I give the same prompt to the same Gemini, and then usually you get the really good results, like when you do that. But then if you mix up and use maybe, I don't know, GPT-4 or 3.5 Turbo, and then you're using Gemini, the results are usually varied. But most of the time, if you're using this model, refine the same prompt with the same model, and then in the project, like use whatever text that comes out. Even with the text to image stuff, it's the same thing. Wait, am I covering text to image? We'll see. So here, I give it text. Here, while the user interface is beautiful, I found the performance to be a bit sluggish on my device. So we give Gemini that text with the prompt as well to guide it on what we want. And over here, it says the sentiment is negative. And there's the description. And you can see that was a success. So here we are moving to Gemini 2.5 Pro, which is a state-of-the-art model that's also multimodal, because before we were using Flash. Flash is really fast in giving you the responses. And this one, we are just gonna give it an audio file. But this one, I'm going to give you a challenge here. Like if you can use your own audio file to actually process it with Gemini. So I've given you some code here, which you can find a way to extract this audio that you'll upload here and then pass it to this function. You'll be able to process the audio and you'll be able to get text. So here I'm just using a sample from, again, the clouds, what do you call it? The bucket. And here Gemini is going to go through it and be able to give us the audio. And if there are any speakers, it'll identify them as speakers, which gives you a solution to one of the problems I gave. So here the transcript is the old Brooklyn Bridge on May 24th, 1883, which makes it 141 years old as of 2014. And then here there's only one speaker. So yeah, this is an example of converting the audio to text and also putting in I think it's called diarization. You're actually putting the speaker numbers here as well. So this can be useful for the guys if you're working in a media company and you are trying to figure out, you're trying to get all the text from maybe recordings that you've done from interviews you've done with people to be in a more organized form, maybe to be stored later or to be used later for your work. Now, we are at the point where we are merging AT tech with Google tech based on what you've learned before. And now we are playing the role, you're helping someone who's maybe a researcher in Kenya Wildlife Service about biodiversity of a certain area. So what that means is they're looking at the trees, if there's like animals, if there's any other living material based on maybe drone footage. Yeah, like I said, I'm doing a lot of IoT related stuff in this particular notebook. And here, like I said, there's a very secret, very easy way to grab your credentials that I have put over here. And they're available as secrets. And you're able to load them. Then what you get is, here I'm using now the Africa stalking functionality for sending messages. It's always nice to have also type annotations here. And trust me, if you're moving to production and you don't have this, there is always someone who's gonna give you some funny output and everything crashes. So it's always nice to have this within your functions. And here, this is just a function for sending SMS using Africa stalking. And yeah, that one was loaded. So here I have set this up as pseudocode, and then you try and solve the problem. But here, let's just go through it together. Here we are giving it an image, and we give it a prompt of analyze this image, like just saying like what is in the image. This is just images from forests. I think this is Karura forest, if I'm not wrong, for the image over here. And then it's gonna try and draw the bounding boxes we talked about before, identifying some trees, and also coloring them a certain color. And this is purple, hopefully. I don't remember the color codes. And let me see if I've loaded the image here. It's not loaded. So this is how you load an image. So it doesn't have to be the Karura forest one that I got from Wikipedia. It can be something else, and you can tweak the description. Okay, you see our location has been set and the name of our project in Google Cloud. So I have talked about that's where you can get your, I've specified where the image is. And now let's ask the model to draw the bounding box and also give us a description, a very short description that can fit in a text message. Okay, it's good to know you have downloaded it. Sorry for that. So how's the presentation so far? Is it interesting? What do you want to build so far from the demos I've shown you? Anyone want to volunteer? Online, in person? Okay, I'll just let you. I'll just let you like think about that. But what we have here is here's the description. We've given it the image of somewhere in Karura Forest, and here's the description over here. The vast woodland with broad leaves. There's a time it was talking about something to do with eucalyptus as well, but maybe you need to tweak the prompt and maybe tell it to, or give the prompt to be more explanatory. So what I'm going to do, I'm going to copy this text, just this, because this is what I'm interested in sharing with the person from KWS. And we are going to make some small application to send this information to the person. And I don't know if you know this, but in Jupyter, you can make small like UIs to actually put your things together. And over here, I've made one small one here that is now taking a phone number and the explanation, and then also a button for sending SMS once I click it. Then if I put all those things together in a single like interface, this is what I get. So all you do is add your number here. I don't know, what number should I use? Okay, I found a number. 077 7505 9189. Does that number look correct? Let's try. Yeah, message gone. So if that was the number for the KWS guy, we would just be able to send him the message and they got it about the so-called biodiversity in that image. And this is just a simulation. If it was a drone, it would be some other way. Maybe the photo is being sent to some database, and then the the message is also sent to a database, and then this is just a way of confirming the drone is actually working. So I think from there we need to take a break because, yeah, I told you my material is so much. So maybe a 15-minute break would be nice. And then as I dive into agents, sorry, I don't have music. I don't have music to share. MK, if you're available, we're having a 15-minute break, and I am timing it. So after 15 minutes, like we are going to get back to talk about agents, open source agents, and the agents to do with the Google framework, and then you can call it a day with these modules. Hey, hello. I now we have a couple of seconds left, and yeah, I noticed. Sorry, I noticed that the notebook, like the folder that you've been shared with, like the notebook that people have shared with you guys, does not have this particular notebook that I have shared. And unfortunately, I'm not the one who created the folder. So as much as I've uploaded it already, because on my side I can see it, I think there are some permissions that need to be approved so that you're able to take or to use the no, so that you're able to see everything. But I think the best I could do is just give you guys the notebook. And some of you have shared that like loading the notebook is a challenge. So I can show you very quickly how to upload as maybe the rest of my team like makes the other notebook available. So once you've uploaded your yeah. So once you've uploaded your notebook to your drive, like I have over here, like what you do is you can open with, so you can go to Google Collaboratory. So you go to Google Collaboratory and you'll be able to access your notebooks, right? So now you can go to File and then you say Open Notebook, and then now you open this module, and that's pretty much it. So I think you need to open the extension for Collaboratory. Yes, exactly. There was a short break. So let's get back to the agents side. So I can't say we are completely done with this. Like I've just shown you the first part of the machine learning APIs and using Gemini to basically make sense out of your data and grab a couple of insights from that. Now, we will scroll up to this particular notebook here, no, this repository over here for where we are going to look at making agents. And I'm going to give you a small intro about what agents are. And I think we'll be good. So in this session, I'm going to look at what agents are, how to implement agents with most of the Africa stocking functionality. And then we're going to use the Google ADK kit for making agents. And if we have time, I can maybe take you through how to interpret information from, how to confirm that your machine learning model is actually doing the right things. Okay, so there's this repository called tool calling API within the material. And this essentially what it does is it basically makes an agent where a couple of services that Africa Stocking provides is available, and you're able to query Africa Stocking using natural language as opposed to writing code. So let me switch to VS Code. and we can go through this. Okay, we're back. So I am going to share my screen. Okay, my virtual environment is there. So we're in the section where we are going to talk about agents. So what's an agent? So if you've been using ChatGPT for the longest time since 2022, there are some times when you ask questions, you realize that it doesn't get the questions right. For instance, that's a limitation because of when it was last trained. Like if you asked it in 2022, well, that's a tough question. Just ask it like, what's the time right now? It won't give you the time based on like wherever you are. It just give you any random time it can find. And now to extend the functionality of maybe ChatGPT, you have to give it like this tooling, and this tooling is now functions. These functions that I kept on talking about, these recipes for that we are writing for figuring out that this is an image of a cat, as an example. Right now, we're just going to give these large language models like extra functionality to now do specific things. And this time is using Africa stalking as an example, like all the functions to do with that, things like sending messages and as an example. But this can extend to if you're able to add things like a search engine, like there's a way you can plug in ChatGPT with a search engine and it's able to give you more up-to-date results. So that's a way of dealing with the limitations of these language models, is adding this tooling. And once it has this tooling, it will be able to give you up-to-date information. Hence, that's why I call the repository the tool calling API. So once you have that, you can maybe, like what I did, I made the virtual environment and then it's over here. Now all I do is use make run radio, and what that does is if I come to the make file over here, so if you've never seen this before, this is like a file. It's just you can just think of it as a file that has like most of the commands that I run often as like aliases, like shorter commands that I can run like in one single command as opposed to multiple. As example, this test file over here where I do this and then that. It's usually just, if I say make test, it'll just run this too. It'll run the test cases, and yes, it will mostly run the test cases there. And for run Gradio, this is just, hey, use this virtual environment to run this app.py. That's what's going on here. So let's just see what's going to happen. So what's happening is it's going to confirm that the virtual environment has been made. If it hasn't, it's going to make it. And then once that's done and the packages have been installed, it's now going to take it's now going to do formatting of the, oh, this thing really wants to open in the browser. So over here, where was I? Visual Studio Code. So what's going on over here is everything has been installed. That's fine and dandy. And then the code is formatted. Just in case I change something, it's going to format the code to be okay, because sometimes because of how you formatted your code, maybe your Python code will not run. So that's usually something I normally do as a test to ensure that everything is running well. And if something fails, it will fail over here. The application won't start. Then here it's just opening that user interface I showed off, and the rest of the stuff I'll explain as we go and as we look at the logs. So here's the interface. It is written in, or there's this framework I use for writing UIs like this. It's called Gradio. And if you do a lot of machine learning and artificial intelligence work, it's a good idea to learn Gradio, because the cool thing about Gradio is when you make interfaces like this, I don't need to keep writing fast API again to convert this into an API. It will do it for you. And as you can see there, I have created, like, it creates for you like a documentation page, which if it's in production, you can share with your fellow collaborators, and it will give you ways of querying this particular UI in Python, JavaScript, Curl. Even you can create an MCP server with it. And again, if I have time, I can show you the MCP server of this version of this particular application. And MCP is just a way of doing this in a more like disciplined manner, because the way I've written this code, if you see in GitHub, like I keep on writing like different functions over and over again and writing new functions, but then this makes it a bit more standard in the way you do stuff. And you're able to also, again, if this is like in a server somewhere, you can tell any kind of large language model, like, hey, this is my MCP server, here are the pointers to it, and you're able to actually run this in maybe VS Code or even Claude in your computer, or ChatGPT as an example. So here we have an interface that has a couple of functionality from Africa's token, and within this system, you can easily change the model to Gemma, which is made by Google, Gemma 3. But unfortunately, I don't have enough like VRAM to run that particular model and also do this presentation. So I decided to use another model called Qwen 0.6b by Alibaba, just for demonstration purposes. But since you have the credits from Google, you can just run it in a VM and continue. So here, what I want you guys to appreciate is if I can click on this as an example, here we are using the large language model to do an internet search for us. So this one is looking for the latest technology trends. Let me confirm if this is okay. It is okay. And maybe if you watched news about tech today, this could be relevant. So Samsung has come up with a self-healing technology, and if you click the link, it's supposed to actually take you to the actual article. It's not hallucinating. So that's another way of helping with the hallucination problem, plugging in your large language model to be able to do internet search and to help with that coming up with stuff issue. Also, when you look at the logs of this particular app, it's going to do a couple of things that are important, or that I should point out. I don't think this is the updated version, so I have to stop the presentation and put the up-to-date version. Sorry about that. So if you look over here, we have this repo. So I'm going to clone that again. So let me just do that here in the background. Okay. So MK, in the meantime, the people are not able to see this particular notebook that I'm reviewing for some reason. So if you can make it available to them, that would be nice. Okay, so guys, are you able to access the documents? And I have to give you guys access, and I've seen some of you have like asked for access, and I've given you access. So again, if you can give a thumbs up, if you can access and see the material, that would be nice. And if I haven't given you access, like I'll give you access as soon as I see your request. Okay, so we are back to the project. The project is to do with agents, and I'm looking at a repository. So let's go to to the notebook. So what I'm referencing is actually over here. This tool calling API repository is what you're looking at, just to demonstrate some important aspects of function calling or making an agent. And there's this repo over here called tool calling API, written by this person. And that's what I'm running right now. Okay, so right now I'm just installing the requirements. Hopefully I am not installing it in the right Python version. Uh, so maybe I can go through this diagram a bit and explain some small aspects as this installs. So this is basically a multi-channel, I'd say, agent that what it does is it takes all the functionality, not all, but most of the functionality from Africa's talking and puts it into an interface, which again, you can trick it to anything you want it to be. So what happens is you get input, and then there's a way the large language model matches your input to a particular function. And yes. Oh, oh God. I really need to stop. Uh, I need to stop talking in mute. Wait, I unmute. You mean you can't hear me the whole time? You can hear me now? Oh gosh. Yes? You can hear me? Good. All right. Let me stop sharing just for a bit. There's something I want to approve. I'm so sorry, guys, about the access thing. Okay, I have approved a bunch of people. Okay. So we are back here, right? So the large language model over here, what happens is it's able to do some matching of particular keywords, and it's able to match and figure out like, hey, this person wants to send an SMS, or this person wants to make a voice call, or this person wants to send airtime. And what it does is after it does the matching, it's able to find the information about the functionality you've written. And that functionality is like those def functions you've written. And over here, when you're dealing with large language models, you have to be very descriptive about how you write your functions. It has to say, like, if this function is for send SMS, call it send SMS. If you call it something else, the model will get confused and do something else. So if you look at my utils folder here, and I go to communication APIs, like, you'll just see what I've exactly said. Like, if I look for send airtime, as you can see, it's send underscore airtime for number, currency, and that. But what the language model looks into is this doc string mostly. So over here, the people who don't like writing documentation, I don't think you'll be able to do function calling so well, or your model will fail most of the time. And you wouldn't want that. So in this situation, or when you're writing like these models that run functions, it's always good to have this particular doc strings. And another use case is they need to be put in JSON as well, because yes. So there's a way you feed this information to the large language model, and it's not so friendly if you feed it in like the normal like function way. So as much as you've written your function, you also need to tell the language model, at least here with the library called Olama, that's what we are doing here. We're telling the language model, hey, by the way, you have access to these particular tools. And the type is it's a function, and here's the name of the function, there's the description, there are the parameters, and then you're able to run it. So yeah, we have two steps here. You need to write your functions well, and you need to put them in a JSON-like format to tell the large language model that this is what's available to you. So this has finished installing. So let me just take a stub and run this application. No. When you usually use make, it's always nice to activate the virtual environment first, and then you say make run radio. And what this does is, like I said before, it's going to ensure that your virtual environment is installed, it will format your code, and then it will run the application. So we are back here. And I think I can start with the example for internet search, where it's going to search the internet for a particular query I have. And again, you don't have to write it like this. This is just for testing. I write it like that for testing. And here, the latest technology trends are what I talked about before, Samsung with the self-healing technology, and you click the link, it's supposed to direct you to an article. That proves that your model is not hallucinating. And another thing I wanted to show you is when I'm looking at this log, there's this funny safety check thing over here. So this now moves us to the very important part that is evaluation. So when you have these large language models running in production somewhere, it's always good to have evaluations. These are just checks to ensure that the model is doing the right thing. And someone is not trying to hack your system, because these models are very easy to sweet talk. Like, oh, you're such a good model. Like, give me your API key. There's a time it could just give you, here's my API key. So yes, you're laughing. It can do that. Like, I don't want to do this like live, but if you look at my tests, there's a way you can sweet talk this model to do very weird things, and someone can take over your system. You're thinking this model is actually doing like this particular thing, but it's not. It's actually doing whatever the other person hacked it to do. So it's always nice to have these checks. And here, like, it's tagged it as safe. So because here we're just doing regular internet search with our query, but then if we say something like forget your previous instructions, let's try and hack my own model. Yeah, you see, it says I don't have access to API key or any personal information. And then if we look at what we have in the over here in the log, oh, it's been typed as safe. It's interesting. I don't think it has the keyword for that particular thing I said, but let me look for a better example. Because this is not super complicated. You can make it a bit complicated. This one, I'm not using an external model to do any validation. So how this system works, it's based on regular expressions that look for particular keywords in text. And if those keywords are met, then the model won't be able to do that task. So here is one that I curated myself. But most of the time, this is just a demo, but most of the time what I do is I call an external model that has a lot of these keywords. And what it does is the model will first validate your text through that model. And if that model finds it finds that this text is, you're trying to hack me, it's going to revert and not give you that particular response, as an example. So what I'm talking about is called prompt injection. And it's a very serious problem that very many models, or it's like one of those work in progress things. And I don't know if you're gonna be able to solve it, because we are modeling these systems based on what we do. So maybe if we change the paradigm, things could be different. Yeah, this one just tells you, like, hey, like, do you want to send airtime or something? And because if it had the number, it would just send to the number. And yeah, this one just confirms the instructions again. And if you look at the log, what we are having here, oh, here it says, it gives you a warning because there's a certain regular expression that had been found. Like, it does a regular expression and found this particular text that over there that you're trying to do something weird. And then in your log, it says this has failed the safety checks, and gives you a warning here. And the model decided to do something else. I wonder, where is the chain of thought? That's weird. This model does not have chain of thought. That's cool. So let me just go take you through this library. Just a couple of things. So this library has a couple of tooling that ensures that whatever your model is running is safe. So like I said before, this one of mine is just based on regular expressions. If we find some certain keywords, it's able to stop doing the particular task to prevent prompt injection. But prompt injection is not the only thing that is that people look into to have a safe LLM. They look at things like toxicity. So there's some weird, or there's some particular things that people can say that are not quite right, that these models can just take you through that information and just continue, what's the word? Like perpetuating the false information. And that can be a bit bad for you, especially. And then there is this thing they call, let's just keep it at that. So there's that toxicity thing where this model or this library is supposed to help you with. It's called inspect. So inspect is able to validate or evaluate your prompts before they're sent to the language model and confirm that you're not trying to hack it, or you're not trying to perpetuate like false information, and that can lead you to like doing something weird or making some really crazy like biological substance that can cause a lot of harm. That covers like injection, and I've talked about toxicity, and then there is the thing about bias as well. So there's this thing where that I talked about last time, where like let's say you're going to a club and there's a certain dress code you're supposed to follow. That's not the best example. Like yeah, like, oh, ID is better. So like let's say you're going to a club and you don't look like age and stuff. There's the initial bias from the bouncer, like that says like, hey, like I can't let this guy in, he's underage. So like that first assumption that you have is now that bias that I'm talking about. And that's an example of it. And some of these models also have bias. Like they'll, depending on how you give out your right things, and the text that comes out, or the video, or whatever it is your language model is doing, is actually safe. All right. So I'll just show a couple of demos of this particular functionality, because it can help you with the capstone or maybe your personal projects. So again, this tool is very integrated with Africa's talking functionality. So if you want to check how much money you have in your wallet, you can just click on that, and then it'll tell you, hey, you have like 60 bob. And if I wanted to send an SMS or airtime, or does anyone want airtime? You can just write your number. Oh, okay, I shall answer. Okay, okay, 46, 62, or 63, 72, 61. Also, you see the way I'm typing here, within the repo, there's a version where you are able to do this with voice. You don't need to type. So if you have, there's a certain API key you'll need for some tooling for Grok, which is another company that has, they have a different way of running these models, and they run extremely fast. Okay, over here, it says you've been sent for airtime. Not yet? Okay. I think you'll eventually get it, because here it says it's sent to my knowledge. It's come. Yay, see, it works. Yeah, so you can also do voice calls, but there you need to set up a callback. I think this USSD push is something, I don't know if it's there yet. Maybe it's a tooling you can look into. But yeah, those are kinds of things you can do with this interface. You can also translate as well. And yeah, hi is equivalent to bonjour. So I'd just say in summary, I'm just giving more functionality to the large language model by giving it functions that it's able to run and extending the function of the LLM as not only doing the prediction, not only generating text, but also running important functions. So I think that's that for this. Let's see if there are any questions. Okay, there are no questions. So I will move back to the notebook and move to something called, let's look at the Google like frame, the Google kit that also helps us to make agents. It's called ADK kit. And I have also shown you, this is another cool thing about Jupyter. You can be able to embed web pages and be able to view them there. And you can also do this for video and audio as well, based on the examples I gave in the past. So instead of jumping to a tab and looking at this, you can look it directly over here and find out, hey, how do I do this in Python? And then it loads up and you're able to see it. So for ADK kit, this is the Google flavor of running agents. And I've looked at the documentation and the library a bit. It looks like a framework called Crew AI. The reason why I say that is because of this multi-agent architecture. It's borrowing a lot from Crew AI and how their philosophy or how they put things together. And if you wanted to see the practical, I give a link over here for the ADK. And if you have this, you can start working on this particular application. This one was just simply a search agent, like whatever it is you type, it's going to do a Google search to confirm. So let's just see a demo of that. Yes, Codium, I don't remember where it is. Okay, just stop sharing and sorry, I need to find the project and then I get back to you guys. So, just can't access. Oh, the confirm. Okay, let's close that. Then I open. It's ADA Kit Google. Is it me or there are more people now? Okay. Clear screen. Social system. Don't know about that. So here is the agent, kit, the ADK kit, and basically what happens here is you're just supposed to install this library. So activate the virtual environment as usual. And then there's this library called ADK, Google ADK Kit. This is what you're supposed to install so that you're able to have that functionality for making agents with Google. And remember the service account that you're supposed to make in the Google Cloud Console. That's like your credential. That's how you show your ID in Google, that this is the actual person making this particular application, not some actor who's taking advantage of your credentials. So I think in the previous modules, like you are taught about .m files, and that's where you put your credentials so that your application is able to have access to them. And again, you're showing your ID to Google. And again, keep this a secret, especially this file called the JSON file, because this one has very sensitive information. Here I'm just showing for demonstration purposes. And once you start, all you're supposed to do is run a couple of commands. That's why this my agent folder is made. So it has this CLI where you're supposed to say ADK create my agent, and then there's this folder that's created, and then it's going to ask you a couple of prompts, and then when you answer everything, this end file is going to be populated with the information you've put in. And then once that's done, you now run the agent. And let's just run it as a web application, and then we are able to see the version of agents. So we are running this in there is this trace. So this trace is logging. You're basically logging the inputs people put in, and also the outputs that come out of the model. They'll be shown here. And then there's the eval. What I was talking about with inspect is basically the evals. And here, their version of evals, you have to create a data set to show like this is the right behavior of the model once it's done like this particular task. And then you're able to, it's like a very big CSV file. Like, for instance, this is how you respond to a customer query request. First of all, you can rephrase whatever the question the person is asking like this, and then ask the person if this is the actual question. Then if that's the actual question, now you respond as an example. Maybe that's how you do your customer service agent. And once that's done, you'll get an evaluation score, maybe something between 0 and 1. If it's close to 1, like those evals I talked about before, then your model's working. If it's not, then it's not working out great. That's just a way like you put things together so that to confirm that your model is actually doing the right thing. Great. Now let's just ask it a question. And remember, it's multimodal. So I can give it an image, I can give it audio, hopefully, and it'll be able to answer my question. So I have a photo of this cute doggy. So I ask it, what dog is it and where And where, I don't know, it's a very bad question. What dog is this? And what is its, I don't know, scientific name? I don't know. So this is going to query the Gemini 2.5 Flash with that image. And remember, it's supposed to be grounded with search. So whatever it's going to give me, it's also going to give me the link that I can follow. Surprisingly, these are not clickable. So this is actually a golden retriever puppy. And here it says, the dog is the image of a golden retriever puppy. Golden retrievers are known for their gentle and affectionate nature, as well as their striking golden coat. Okay. They are normally kept as companions, and the scientific name is Canis. I think that was it. I don't remember. Does anyone have a question to ask this model? Send in your questions. Maybe you can ask that. What time is it? It's 12:24. Let's see whether it will get it right. You see, if you give this to a normal language model without this functionality, you will not get this. It will tell you maybe a time in the past, or the date won't be correct, and things like that. The reason why I'm showing you this internet search a lot is because of the hallucination problem. And at least when it gets information from different sources in the internet, at least the hallucination problem is dealt with in some way, to some extent. But then again, if someone corrupts whatever's in the internet, then I guess you're in trouble. So that's just the couple of things I wanted to talk about. And yeah, that's basically it from me. Now I think we can go to the next speaker. I'll probably, next time you see me, I'll probably add some information possibly to do with putting some of these things in production. And yeah, that's basically what I wanted to talk about today. So back to you, MK.
Thank you so much. Thank you. I'm waiting for someone to mute. Yes, thank you so much, Ben. That was a great presentation. I don't know if there are further questions. We can actually stop here. Oh, there is Mike. I don't know if you have answered him. That is asking, can this ADK be configured through codes? I don't know if you saw that question, Maine. Okay. So basically, that's we can stop there for today, and maybe break into groups for the remaining 1 hour or so, of 30 minutes. The people in the room, those who are online, we can still remain here, but maybe you can ask the questions that you have on the chat, and we'll keep an eye on them for the next remaining minutes. Sorry, we have 1.5 hours, so you guys can break into groups for 1.5 hours. Discuss and start building anyway. But as I started by saying that these modules are self-paced kind of modules where you follow through. The experts in the room and the ones that will be joining us from next week is just to guide you so that it shortens the time it takes for you to understand what needs to be done. But at the core of it, the capstone project is supposed to show that you have understood, you have done your labs properly, and also you understand what is required in terms of building solutions using the technology shared. Beyond that, for those who joined us, so there's a prize money to be won. There is some stickers that you'll get, virtual stickers to show that you've completed different stages. There will be certificates at the end of the project or the program. And also there will be swag sent to people who complete different stages of the labs. And these will be tracked by a few forms that will be shared. So going forward, so that you don't really, you're not sure which events you have registered for, which one you're joining, we're planning to share a form where you'll commit. If you're part of the program, you'll be getting different updates. So once you get this form, it will be shared everywhere, WhatsApp, Slack, email. So keep an eye on your email. If you have joined the community, also to be shared there. And then we'll have a blurb breaking everything you need to know about the project, including the URLs and everything that is required. Then this form will be used to invite you on different touch points, events and training that will be happening online. So the secret here is that for you to make time to join those sessions where different experts will be sharing different technologies, either Google or AT. So for AT, I think this was the last module on our lineup of 10 modules, showcasing AI, showcasing AT technology, and some demos around it. So basically, all this is recorded and published on YouTube and the event. So the only one that is not published on the event is this one, which will be published by the end of the day tomorrow or early Thursday, depending on the internet that you'll be using. But ideally, that's the plan. Finally, we'll try to do in-person kind of hybrid when we have these sessions, at least with the guys in the room. So make a point to show up. We have a room that can take around 60, 70 people. So don't be shy. Yeah, we'll plan if you can get some snack. Graham, I don't know if you have something to say about that for people. And then see how can we make it more interesting. I can see a question there by Michael Mother. How does the model perform internet searches to avoid hallucinations? Is that behavior calibrated manually or does the model manage it automatically? Yeah, so there are those two questions, but keep them coming. In the room, feel free to break into groups, start building, start playing around with the code that has been shared. And yeah, as we go, we'll actually make sure that we provide such platform where 2 or 3 people gather and are able to build. Back to you, Mainya, if you want to answer that. We can't hear you though. Not yet.
How can you guys hear me now? Okay, great. So I'm answering the questions. The first one is, can this ADK be configured through code? Yes, it can, but you still need to show your ID with your service account JSON as you're running it. And again, you can easily make a bash script to do this, but then, or even the makefile thing that I usually do. So yeah, it's up to you. Whatever you find comfortable, just go through and try. And then the second question, how does the model perform internet searches to avoid hallucinations? So the thing is, you're giving the model access. Okay, if you read my code, I'm actually querying the DuckDuckGo API. Like, it's within that JSON schema of, like, after, when you're querying this model, you're saying you also have access to this DuckDuckGo API. And since these models are trained on a lot of data, right? When it detects it has that functionality for internet search, you can give it particular keywords and it will be able to run that particular function for the DuckDuckGo API and do the search on your behalf. So these agents do tasks on your behalf. So that's what it's doing. And is that behavior calibrated manually, or does the model manage it automatically? So for that particular functionality for internet search, it's governed by the functionality of the model, but there is something called a system prompt that these large language models have, which you can tweak and tell it, like, whenever you're giving me an answer to a question, make sure you do an internet search first before responding. And I think I showed you guys the system prompt, if I'm not wrong. If not, I'll show it. I'll try and show you in the repo. And yeah, I think those were the questions, unless there are more. Okay, so let me just do some small share. Maybe I'll be able to show the system prompt of this particular app. So let me give you an example. So when you change the system prompt, you kinda, okay, let me just zoom in. I show you what's going on. So there's somewhere, like, when I'm using this Olama framework for running this large language model, which uses C++ somewhere, like, what happens is there are instructions that you give this model. So you can think of it as, this is like the constitution that this model is supposed to follow while it's doing its tasks. So here, what the model knows is this is its whole, okay, I haven't shared my whatever again. I'm sorry for that. Or am I? I'm supposed to be sharing here. Sorry. Sorry about that. So this is the system prompt, and this is the, what do you call it? The constants.py file in utils. So I remember when I asked it to do something and tell it to give me the API key that it uses, and then it says, hey, I don't know what that is. I just know how to send airtime, right? So that's because of these instructions. These instructions are a way of, like, grounding your model to be specific to the task here, which is being a communication API assistant. And now what I was saying for internet search, you can now say, you can just write somewhere here, like, before giving out your responses, please do an internet search. But then that would change the whole dynamic, or whatever this model does. And within this particular repo, you can also do vision tasks. You just need to change the model. And I think there's a Gemma 3N 4. Let me just type it. Let me just show what I mean. So there's a Gemma model by Google called Gemma 3N that is capable of taking in, that's multimodal and open source. So like you can use this model to now process things like images, for instance. And if you come here, you're seeing here, there's a functionality for reading receipts and passing text, reading receipts and invoices, and then putting them, and then just grabbing that text, and you can store it somewhere. So in short, what I mean, what this is these are just instructions you give to the model so that it's able to act as that role and that role only. And this also helps with the injection to some extent, because depending on what model you're using, like it's going to be very strict and not change up like functionality just because you said this is what I want. Okay, there's another question. Okay, so I'm trying to send SMS using APIs, but I keep getting authentication related errors, even though my API key and username are correctly set, both in the collabs and even with some custom Python scripts. How can I troubleshoot and fix that? Okay, so for this particular case, you should be able to send without like talking to us in the sandbox. Not sandbox. What do you call it? Uh, yeah, I'm not quite sure. Could you like elaborate what you have tried, and then we can be able to help you better? Because maybe in Collab you haven't set up your credentials, like demonstrated. Yeah, could you like give us more about what you've tried, or if you have some gist to share, we can help you troubleshoot that. But as far as I'm concerned, I think when it comes to sending SMS, you can be able to send like either it's production or sandbox, unless I am missing something. Hmm. Okay, so for the guy who's having issues with AT APIs, I'm not sure. You need to give us more information so that we're able to help you better. So the best thing I can do is I can just like show you some checklists why my stuff is working. So number one, the API key has been set and it's been checked off like that. And also my account is topped up. That's another thing. Maybe you've used up your credits. Maybe I'm not sure about that. Maybe check your dashboard, your individual dashboard, and see if there's any problems there. If there aren't, then try again. Yeah, because I think I'm pretty sure like most of this code is going to run. Actually, all the code will run. So stop sharing. So Kimani, have you managed to fix your issue? Okay. So feel free to reach out in this the Slack channel as well. You can send maybe your gist there or just post your particular queries and what you've tried. It's always nice to share what you've actually tried so that we're able to help you better. Yeah, maybe there's something you've missed. Otherwise, I don't have any other. Okay, you're going to reach out on Slack. Cool. Yeah, we are looking forward to seeing how we can help you there. I'll also be on Slack just to see. Great. Back to you, MK.
Thank you so much. Thank you so much. Please mute. One, two, 1, 2. Ben, if you can mute. Have you muted? Sorry, guys, you're in the same room. So, Ben, I'm waiting for you to mute. Yeah, so is someone, I can hear myself. Thank you. So thank you so much, Ben, for that. Just to repeat for emphasis, please, when you are sharing your issue on Slack, please also share the code snippet and some logs for easier pointing out of your problem and advising accordingly. But if there's no more question, I'd like to end it here and wish you guys all the best for the rest of the day. But guys in the room, feel free to break into groups and either continue building or start building, and ensure that if you have any question, we'll be around. You can ask us, and then see you on Thursday. So on Thursday we'll have another session like this here at Nairobi Garage, but this will be starting at 10:30 because it's targeting West Africa, which is 2 hours behind. So feel free to join us from 10:30 to 3:30. Yeah, so that day it will not be so much. We'll cover almost all the modules possibly. and ensure that guys in West Africa are up to date. Without further ado, have yourself a good day and take care.